Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So please tell me, am I properly audible and visible to all of you or not? Then we are starting the session. So guys, you know that this session was about to be done on yesterday's class, as this is the second part of strength of material. In the first part, we have done questions on simple stresses and strain, bending and torsion, principal stresses. And in this session, we will be having the questions on SFD, BMD, deflection of beam, column and theories of failures and thin pressure vessel. Rohit, good morning, dear. How are you? So with this, we are starting the session. Am I properly audible and visible, Rohit? So we are starting the session. This is for ISRO 2023. So guys, as I already told you that here this is going to be practice as well. And for your request, many of the students said that, sir, it would be better if you share the formula sheet on the Telegram. So based on that, I decided that now every subject revision formula sheet you will be getting on my Telegram channel. So what is the advantage of that? You can revise by yourself. Okay, so you need not to be dependent on the session for revision, and you can revise anytime whenever you want. Okay, so keeping that in mind, you will get the same formula sheet today only. Naruto, good morning. Vinay, good morning. So we are starting the session, guys, without wasting the time. Okay, so this is some detail about me, and today's session is related to the strength of materials, guys. Yes, moving further, Pajal word, good morning. Yes, so guys, do like and share the session. Today at 7:30 p.m. you guys have a workshop, tricks to secure 15 out of 15 aptitude in GATE 2024, will be taken by Rakesh Salreja sir. So you can register for this workshop for free. And now we are starting with the question. So this is the very first question, guys. Very first question. For the simply supported beam shown in the figure, at what distance from support A the shear force is going to be 0? At which point shear force will be 0? I feel everybody is aware that when shear force is becoming equals to 0, or you can say changes a sign from positive to negative or negative to positive, then bending moment is becoming maximum. So guys, they are asking indirectly where bending moment will be maximum. As this is a standard case, so it is assumed that you would be knowing that, and for that we need not to solve this question. So I am waiting for your answer, Rohit, Vinay, Naruto. Yes. And guys, I would also like to add, if you guys are very much seriously preparing for ISRO, then as this session is related to the strength of material, so at 11:30 a.m. you can join me on the app as well, where I will be taking a most repeated question of production. There we will discuss 20 questions from the production plus material size. Okay, Pajal would have given the answer to be D. What about others? What about others? I feel everybody would be aware for this kind of loading condition. Here we get WL by 6 as the support reaction, and here we get WL by 3. So these are the support reaction you will get. Okay. Then my dear, we will be going for SFD. If you talk about SFD, then my dear, SFD for this case will be coming like this. You will be having, take this section to the left hand side, it is positive. So this will be WL by 6. And this will be WL by 3. And as this is inclined line, you will be having a parabolic SFD like this. So here you will be getting shear force to be 0. The distance will be L by root 3. And at this position, if you will see the bending moment diagram, it is found to be maximum like this. Okay. And what is this? This is WL square upon root 9 root 3. So as I said, this is a standard case. It is expected that you would be knowing about that. Manikanta, good morning. Ayush. Yes, so guys, I know that you would be expecting this session yesterday. It was about to be there, but as I said, because of some technical issues, it was not happen. So today we have this, but other schedule will remain as it is. So tomorrow you will have fluid mechanics session by Chandrasekhar sir, 11 a.m. Then after fluid mechanics, we will be having engineering mechanics, industrial, TOM, production. Likewise, we will have. So guys, the answer for this is going to be D. Moving further to the next question, guys. This is question number 2. This is question number 2. So guys, the maximum bending moment due to a moving load on a fixed ended beam occurs the maximum bending moment due to a moving load on a fixed ended beam occur? This is the fixed ended beam. This is a very simple question. Yes, Manikanta, Ayush, Pagelward, Naruto, Vinay. I'm waiting for everyone to answer. Question number 2. Question number 2, guys. You need to tell where you will be having the maximum bending moment in case of both hand fix. Pagelward is saying B. Okay, what about others? What about others? Okay, Dukhi Atma. Okay, so as Adarsh is saying B, Naruto saying B, Dukhi Atma is correct, because you know that whenever we have fixed support, these supports are also creating the reactions like this. So if whatever be the load you will have, because of this, the maximum bending moment will be occurring either at this support or at that support. Why? If you are going for symmetrical loading, then you will be having the load, the resultant load at center. Then my dear, at both the reaction, the distance is equal. So if this is P, then my dear, you will be having this to be PL by 2. But my dear, if this P is not at this position, let us say we are having this fixed beam and we are going to have the load is not symmetrical, it is, let us say, triangular loading. Then you can take the total load. Let us say the loading is like this. So you know the total load can be assumed at which point? At the centroid, like let us say this. So let us say this distance is 2L by 3. This is L by 3. So because of this, bending moment will be coming maximum at this support this time. This is, let us say, total load is WL by 2. So it will be WL by 2 into 2L by 3. So the point is, for such cases, bending moment is always coming maximum at the support. So guys, that is why I added this question. You can see this question in ISRO 2023 as it is. So these type of question where no calculation, but still you can see only one student have given the right answer. That is the beauty. So this type of question you can expect, because this time written is having the weightage for the final selection. So let us move further. Everybody clear about this? Everybody is clear about this? This is question number 3 now. This question is saying that if a beam is subjected to a constant bending moment along its length, then the shear force will be. This is a very easy question. So I have added all the types of question. Every question is not difficult. Some are easy, some are tricky, some are lengthy, some are calculative. What will be the shear force? And I am telling you guys, at 11:30 today only, on app, we are having the most repeated question of ISRO. Okay, from production and material science. Okay, and from this Saturday we will have app session also. Okay, so this time I feel everybody is giving the right answer. If bending moment is constant, shear force is 0, because we know shear force is dm by dx. So if bending moment will be constant, shear force will be 0. So this is going to be this. Okay, so Dukhi Atma, what you are saying, this is the assumption. Pagelward, I don't know why it is, but if there is a problem, I will try ki wo unblock ho jaye. So as I said, my dear, this is assumption. What you are saying is that is for the pure bending condition. Otherwise, this is not every time a condition. For using the bending equation, we assume bending moment is constant. Otherwise, when bending moment is constant, obviously shear force will be 0. Moving to the question number 4. You can say we are assuming self weight. Obviously, because of assumption, we are reaching to that point. So this is about bending moment diagram. Let us see how many of you give the right answer for this. This is question number 4. Question number 4, guys. Which of the bending moment is correct? First of all, you need to see whether they are in same direction or opposite direction. then you will get the answer automatically. Yes. What will be the right answer for this? Suraj Kumar is saying B. Rakshit is saying A. Very good, Rakshit. Vinay is saying A. Answer is A, guys. Because first of all, you can see that this is point C, this is B. So you can see at C there should be a jump of 50 kilonewton. At B there shall be a jump of 30 kilonewton. So two jumps should be there, okay? At C and B. Obviously at A also jump will be there. So you can see at C jump is there, at B jump is there. Here at C jump is there, at B jump is there. Here at C jump is there, at B there is no jump, so D cannot be the right answer. Here we have the jump at C, but we don't have the jump at B. So that is why C cannot be the right answer. Now we need to choose either A or B. So you can see here they are having 50 and then it is reduced to 20. So 50 and 30 are in opposite direction. So obviously A will be the right answer. Here they have added it. Okay. That is why B is also wrong. So moving further. Very good. Very good. Rishabh. Yes. Moving to the question number 5, guys. So these are the exact level of ISRO questions. So you can directly follow this. So guys, do you want us to come with the mock test also? Now we are planning we will come with the mock test also. Okay, but first we have a plan of starting aptitude from Saturday. From Saturday we will have aptitude sessions also. Every Saturday aptitude. Okay. In the case of I section, the web resist mainly. First of all, if this is the I section, then this is the flange. This is the web. Yes. Rakshit saying B. Dukhi Atma B. Okay, Rishabh B. You can download the PDF of this class from my Telegram channel, Mechanical by Dheeraj Sardana. Okay. So everyone is saying the answer as B, which is correct answer, because you know that whenever we are talking about the bending stresses, so bending stress distribution is like this. So bending stress is maximum at the flange part. Okay. So that is why web part is not bearing much bending stresses. But shear stress distribution is coming like this. So obviously shear stress is maximum in the web part. So answer will be shear force. Very good, guys. Moving to next question. Question number 6. Question number 6, guys. Yes, a 10-meter long beam carries point loads. When shear force diagram is drawn, there are two rectangles of 10 into 2 meter side. Okay. One is starting from one end above the base, other is starting from the other end below the base. This is the SFD. Like this. Okay. Okay, so it is 5 meter, 5 meter. Sorry, 10 kilonewton for 2 meter. They are saying 10-meter long beam carries point loads. When shear force diagram is known, there are two rectangles of 10 into 2 side. Okay. 10 into 2 side. Ten kilonewton into 2 meter. This is 10 minus 10. 2 meter here, 2 meter here. 6 meter in between. This is the diagram. And they are saying the bending moment at the center of the beam is. Dukhi Atma, because you know that force is stress into area. So when stresses are more, force will be more. That is the reason for that. Okay. Fine. What is the answer for 6th question? Dukhyatma, for L section, obviously when you will say, you will not be using for bending, because bending creates more stress at top and bottom. So L section is not good for bending. I section is good for bending. That's why they are asking I section. They will ask a section which is used because of some reasons. Okay. So everybody is saying the answer to be A. The reason is, let us say this point. This is A, this is B. And you want bending moment at C. So bending moment at B minus bending moment at C will be area of shear force diagram between B and C. So you can see this is only a rectangle. So you can write it as minus 10 into 2. And bending moment at B is 0. So it is minus MC. Bending moment at C is 20. Answer will be A. Very good, guys. The answer for 6th is going to be A. So everyone who have answered it correctly. Moving to the next question, question number 7. Question number 7, guys. So we are having total of 25 questions today. Today I will be sharing you the formula notes of strength of material on my Telegram channel for ISRO. You can follow that for revision purpose. So the shear force diagram shown in the figure is that a freely supported beam with symmetrical point loads about midspan. Freely supported beam with symmetrical uniform distributed load at midspan. Simply supported beam with positive and negative point loads symmetrical about the midspan. Simply supported beam with symmetrical varying load about midspan. What do you feel, guys? The answer should be okay. Rakshit is saying B. Manikanta B. Very good, very good. So guys, the answer is B, because you can see from this to this, the variation is inclined line. So obviously loading will be UDL. Okay, loading will be UDL. Okay, so if that is the case, my dear, obviously it is going to be freely supported beam with symmetrical uniformly distributed load about the midspan. So that is going to be the answer for this. Yes, Rishabh, Rakshit, very good. So every one of you have given the right answer. Moving further to question number 8. Moving further to question number 8. This is from theories of failures. So all the theories of failure will give nearly same result. All the theories of failure will give nearly same result. You can see the options. You can see the options, guys. So do like and share the session. Still we are left with 17 more questions. Total 25 questions. When one of the principal stresses at a point is large in comparison to other. When shear stresses acts. When both the principal stress are numerically equal for all the situations. Vinay is saying the answer to be A. Rishabh A. Dukhyatma also A. Vinod Reddy also A. Manikanta A. Pejal Word A. Yes, the answer is A. Because, my dear, I would like to say that in the theory of failure, you are going to compare the combined loading. You are going to compare the combined loading with the tension test. Tension test is the uniaxial loading. So when all the theories will give the same result, when you are going to compare tension test with tension test. Because when both sides are same loading, you will get every time same result, whatever be the name of the theory of failure. So obviously it is possible in uniaxial loading. So my dear, uniaxial loading is coming whenever out of these which situation. For all situation cannot happen. This is the condition when both the principal stresses are equal. Mohr circle is a point, not a uniaxial loading. Shear stress cannot give you uniaxial because here you will get principal stresses. So here one principal stress is quite more than the other. This is the case. So when second will be very, very less, you can compare it with uniaxial loading. So answer is A for this. Moving to question number 9, guys. Moving to question number 9. Very good, Adarsh. The principal stress is developed at a point R. Sigma 1 plus 60. Sigma 2 minus 60. Sigma 3 0. Using shear strain energy theory means MDET. You need to find out the yield strengths of the material. I feel you are aware that they have given factor of safety. You are aware it is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 SYT square upon N square. You need to find out SYT. Find out SYT. Okay, Pagel word is saying the answer to be C. Pagel word is saying the answer to be C. What about others? What about others? Solve it, guys. Very easy question. Sigma 3 is 0. It is two principal stress case. Okay. Everyone, Rakshit, Marikanta, Vinay, Rishabh, everybody is saying the answer to be C. So guys, you know sigma 1 square is 60 ka square plus minus 60 ka square plus 60 into minus 60. Okay, not plus, minus. So minus minus will become plus. So you will be having 3 into 60 ka square. SYT square upon root 3 ka square. If you will take the square root at all the sides, you will have root 3 into 60 SYT upon root 3. So what is SYT? 60 into 3. D will be the answer. D will be the answer. Okay. So that's why I said see it clearly. Generally students are not doing N ka square. That is the problem. So whenever you say sigma permissible, it is always sigma failure divided by N. So when you will say square of this, automatically square of this complete should be there. So take care of this. Moving to the question number 10, guys. Question number 10. Very good, guys. Question number 10. Question number 10. They are saying for ductile material, which theory of failure? For ductile material, which theory of failure? So I would like to say for ductile material, there are two theories. One is MSST, other is MDET. If nothing is mentioned, you will go by MSST. So answer will be B. Answer will be B. Okay. Yes, B is right answer. Naruto, Manikanta, Adarsh, Vinod, Rishabh. Very good. Vinay. Moving to the question number 11, guys. This time they are asking brittle material. This time they are asking brittle material. Yes, very good, Manikanta. Brittle material, guys. Yes, everybody would be aware that for brittle material, we have only one choice. Rankine theory. Rankine is nothing but MPST. A would be the right answer. Moving to question number 12, guys. In a structural steel member, there are perpendicular tensile stresses of 150. This is the case. And they are saying that what is the equivalent stress in simple tension according to maximum principal strain theory? You know, it is sigma 1 minus mu times sigma 2 is equals to SYT divided by N. You need to find out SYT. Factor of safety is not given. Take it 1. Solve this question. Question number 12, guys. So after this, we have 13 more questions. So this is the 50% marks. Okay. So everyone is saying here also the answer is B. It is 100 minus 0.25 into 50 is equals to SYT. So the answer will be B. So you can see this type of calculation we are expecting in ISRO because calculators are not allowed. This is my favorite question every time I give this question. Whenever I take any session, this question is my favorite. Very good, Marikanta. Moving to question number 13. After this, we have 12 more questions left. Yes, Veera is saying A. They are saying permissible bending moment in a circular shaft under pure bending is M. According to maximum principal stress theory of the failure. According to maximum shear stress theory, the permissible bending moment in the shaft will be. This is the question where generally students are making the mistake, and same here I can see only those students are able to give the answer, those who have attended either my classes properly or my practice sessions. So you tell me that all the theories of failure give same result for which type of loading? Give same result for which type of theories? Sorry, for which type of loading? For which type of loading? You know this is tension test or uniaxial loading. This question we have just done. And you know, whenever we are talking about the bending moment, the state of stress, if you will see the state of stress at any point, like at this point, it is uniaxial only. So the answer will be B. So they can say any theory. For all the theories, the answer will be this only. But this is true only for bending moment. If they say it pure torsion, like this, then the thing will changes. Okay, like if they say pure shear is the case, and they say with MSST we are saying that torque requirement is T, then what will be the torque requirement as per MPST? The answer will be 2T. Okay, so if it would be pure shear, then your answer would be correct. Like you said M by 2, at that time you can say T by 2. That would be correct. But for uniaxial loading, it will be same. Moving to question number 14, guys, from deflection of beams. We covered the question of SFD, we covered the question of theory of failures. Now we are covering the question of deflection, after that thin pressure vessel, after that column, then strain energy. Okay, all the chapters are covered. So we are having 11 more questions after this. Two identical cantilever are loaded as shown in the figure. If the slope at the free end of the cantilever in A is theta, the slope at the free end of the cantilever B will be. So I feel you are aware that theta for the first cases, it will be ML upon EI. Theta for the second cases, PL square upon 2EI. So you need to say that if this is theta, then this is how much in terms of theta? Solve this question. Vinod Reddy is saying B, Pejal Word is saying B. Okay, what about others? Look at it carefully. Okay, D you are saying. Dukhi Atma is saying D, Vinay is saying D. So if you see, this is PL by 2, this is P. Vinay is saying D, very good. So guys, the answer for this will be theta only. Because when you will put the value ML upon EI, this is PL by 2. So PL square upon 2EI it will be. Which is this. So the answer will be D. Very good, guys. D will be the answer. D will be the right answer. Okay, this is given the PL by 2. Yes, Adarsh, got it? Moving to question number 15 from deflection. Moving to question number 15. 10 more questions after this, guys. A simply supported beam with width B. Simply supported beam. Simply supported beam. With width B and depth D carries the load W, undergoes deflection delta at the center. Delta is given as what? Like this. If the width and depth are interchanged, I is nothing but VD cube by 12. But when it will be interchanged, it will become DB cube by 12. So then the deflection will become. So right now the deflection is delta in the first case is WL cube upon 48E BD cube into 12. And then deflection will become WL cube 48 dB cube. So you know WL cube 48 EBD cube, that is delta 1. So delta 1 is delta. Okay, very good. So the answer for this question will be B is correct. So it will be nothing but D square by B square into 12 WL cube 48 EBD cube. B is the right answer. Very good, guys. B is correct. No doubt about that. Moving further to question number 16. Once again, now thin pressure vessels. Now questions are from thin pressure vessels, and after that we will be having the Coulomb's question. After that we have the Coulomb questions. A thin cylindrical shell is subjected to internal pressure P. The Poisson ratio of the material is 0.3. Due to internal pressure, the shell is subjected to circumferential strain and axial strain. The ratio of circumferential to axial strain. This ratio you need to find out. Okay. Ha dukhi atma. Yes, you can do by that also. So I feel you are aware that epsilon C is PD upon 4T. Is this 2 minus mu? And longitudinal is or I have written opposite. Yes. Or it will be this. Tell me. Epsilon C is coming from sigma C by E minus mu times sigma L upon E. Those who forget, this is PD by 2TE. PD by 4T. You will have PD by 4T. The answer will be, it is PD by 2T, PD by 4T. So when you will take 4T, this is 2 minus. Yes, 2 minus mu, 1 minus 2 mu. So you need to go for the putting the value of this mu and get the answer. Very good, Vinod. Solve it and get the answer, guys. Solve it and get the answer. Very good, very good. So I have just said that if you forget, then you can follow this. That's why digitally I have done this. Okay, what will be the ratio? This is 2 minus mu. 1 minus 2 mu. Poisson ratio is 0.3. So 2 minus 0.3 1 minus 0.6. Yes, answer will be D for this. 4.25 will be correct one. Very good, guys. Moving to question number 17. For the same internal diameter, wall thickness, material internal pressure, the ratio of maximum stress induced in a thin cylinder to the thin sphere is. What is this ratio? What is this ratio? Thin cylinder and thin sphere. I feel you know circumferential stress in cylinder is PD by 2T. And circumferential stress in sphere is PD by 4T. What will be the answer? The ratio of cylinder to the sphere will be 2. A will be the right answer. Very good, guys. Moving to question number 18 now. From design point of view, spherical pressure vessels are preferred over cylindrical pressure vessels. This is a very good question. Practical question. Practical question. Question number 18. Yes, guys. What will be the answer for this? I will give you a hint here. You have just seen the circumferential stress in the cylinder is PD by 2T. And the same in sphere is PD by 4T. So the maximum stress is, you know that, this is circumferential only. So maximum stress in the circumferential stress in the spherical is half of that of cylindrical. So stresses induced are just half of this. So it means life will be more. So the answer for this should be, are most effective in fabrication, have uniform higher stress, have uniform lower circumferential stresses. C would be the right answer. C would be the right answer, guys. Moving to question number 19. A thin cylinder with both ends closed is subjected to dull pressure P. The longitudinal stress at the surface has been calculated as sigma naught. The maximum shear stress. Closed from both the surface. You need to find out the maximum shear stress. Tau max. They are saying circumferential stress to be sigma naught. Longitudinal stress to be sigma naught by 2. What will be tau max? And you know sigma 3 will be 0. This is the case. Sigma C, sigma L. Sigma 3 is 0. They are asking you tau max. And they are saying shear stress at the surface. Whenever they say at the surface, you need to go for absolute tau max. Absolute tau max. Absolute is maximum of sigma 1 minus sigma 2 by 2. Sigma 2 minus sigma 3 by 2. Sigma 1 minus sigma 3 by 2. It will be sigma C by 2. Is it clear? D would be the right answer. D would be the right answer, no? Why you guys are saying C? I didn't get. Why you guys are saying C? They have asked the maximum. Okay, longitudinal stress is sigma naught. Okay, C will be the answer then. Sorry, I have not seen that. Actually, I have kept circumferential as sigma naught. So if longitudinal is sigma naught, this will be 2 sigma naught. Yes, then it is correct. Sorry guys, I have interpreted wrong. Question number 20th. Now the questions are from the column chapter. Now questions are from the column chapter. Column. Now questions are from the column chapters. Fine, fine. Question number 20, guys. After this is the last chapter. 6 questions are left. Yes, guys. They are saying the slenderness ratio is 160. For a circular column having its end hinge. So, you know, this is LE by K minimum. You need to find out L by D ratio of the column. K minimum is I minimum by A. Okay, and they have said this is 160 as given. Yes. For a circular column, pi by 64, d की power 4, pi by 4 d square. Okay, from here you can find out K minimum. Okay, and sorry, you can find out from here K minimum. And once you will get K minimum, you can solve it. Yes, yes, yes. So the answer will be C for this. Everybody is getting C, 40. L by D is 40. Answer will be C for this. Very good. Moving to question number 21, guys. Moving to question number 21. For the case of cylinder column length L, flexural rigidity EI built at its base, free at the top. This case, you know that LE becomes 2L. Put it and get the answer. Put it and get the answer. 21. Put it and get the answer. 4 more questions after this, guys. 4 more questions after this. You know that buckling load is N square pi square EI minimum upon LE square. Pi square EI 2L ka square. Answer will be D for this. Very good. Moving to question number 22, guys. Question number 22. Three more questions after this. Everybody, Rankine-Gordon formula. It is for C. You know it is valid for both short and long column. Okay, it is because for short column, it says that Rankine load is equals to what? Equals to crushing load. For long column, Rankine load is equals to buckling load. So that's why it is valid for both. Moving to question number 23, guys. 2 more questions after this. Yes. Virodh. Okay. So the resultant cuts the base of circular column diameter D with an eccentricity equal to 1/4 of D. So E is D by 4. Maximum compressive stress to the maximum tensile stress. Okay, I feel this question is, everybody is getting this? You know that compressive stress is P by A. Tensile stress is this will be the case. Answer will be coming as -3 is correct. Very good, Dukhi Atma. Answer will be -3 is correct, because you know this is going to be negative, this is going to be positive. You will say this is minus P by A. Minus P by A plus PE by Z. When you will put the value of A, value of Z, you will be getting the answer to be -3. All other things will get cancelled out. Answer will be A for this. Very good. Moving to question number 24, guys. This is a very good question. A hollow circular column of diameter D and external diameter 1.5 D. So you know, for this case, eccentricity is D square plus D square divided by 8D. Just put the value, get the answer. Put the value, get the answer. Minus sign do not denotes anything. It simply says compressive by tensile, means if tensile is positive, compressive is negative, minus will come. Okay, if it would be an NAT question, then 3 would be a wrong answer. -3 would be correct. Yes, guys. Question number 24. Putting the values. A hollow circular, you just need to put capital D as 1.5 D. They are saying that the maximum distance of the point of application of load from the center for which no tension exists. So I am telling you, this question have been asked in ISRO for at least 5 times. When they said that there is a circular column and load is acting at some eccentricity E, like this, and they are saying find out the value of E for which there is no tension existing. This is the concept of core, kernel and kernel. When you will go, you will get eccentricity value as D square plus D square by 8D. I have solved this question many times in the previous practice sessions. Okay, so this result is a standard one, you can remember it. Okay, so if you will remember this result, then you just need to put the value of capital D here. Anybody want me to get this expression? I have done it many times in the previous practice sessions. So answer will be B for this. 13D by 48. Anybody have any doubt? Nobody is answering now. Vinod, Manikanta, Adarsh. Do you know the concept of core, kernel, kernel? If you want, I can explain if any requirement. Please tell. Any doubt? हाँ भाई, मणिकांता, आदर्श, विनोद, पेजल वर्ड. नहीं, I said only 2 students have answered. Others have not answered. That's why. Moving to question number 25. They are asking you the value of Rankine constant. What is Rankine constant? What is Rankine constant? This is Rankine constant. A would be the right answer. A would be the right answer. Okay. This is the extra question, bonus question for you guys. From strain energy. For the state of stress of pure shear, the strain energy stored per unit volume in the elastic homogeneous isotropic material having elastic constant E and mu will be. Yes. You need to find out strain energy per unit volume. This is the state of stress. Okay, you know that this can also be written like this in terms of principal stresses. So these are the principal stresses: sigma 1 plus tau, sigma 2 minus tau. So you know strain energy per unit volume. It is going to be what? Half sigma 1 epsilon 1, half sigma 2 epsilon 2. Solve it. So you know that epsilon 1 is sigma 1 by 1 minus mu. Because sigma 1 and sigma 2 are equal. That's why we are writing this. Tau by 1 minus mu. Sigma 2 is also 1 minus mu, tau by. So when you have these values, you can write answer will be A for this. Very good, Adarsh, Manikanta, Dukhi Atma, everyone. So guys, everybody got it? Any doubt? Please ask. Any doubt? Please ask. So shall we complete the session here? Yes. So guys, with this we have completed almost 56 question, not 56, 60 question of strength of material. 34 in the last class, 26 today. Total 60 question we have done. And I will be sharing this PDF on my Telegram channel, Mechanical by Dheeraj Sardana. And also I will be sharing the formula notes for ISRO 2023. Very good. Very good, Dukhi Atma. So guys, this is how you can score very good in ISRO. And as per the schedule, you will be having Monday, Wednesday, Friday technical classes at 11 AM. Okay, today the class was by mistake because yesterday couldn't happen. Saturday we will be having aptitude session, and on alternate Sunday we will be going for the mock test. Okay, this is how we are moving with. Now at 11:30 AM you can join me on BYJU'S exam prep app, where I will be going for some previous year's question of production and material science. Okay, so you can join me at 11:30 AM on the BYJU'S exam prep app. Okay, so goodbye for this particular session, and we will meet again. Goodbye.